which is intersecting at 2 points. Okay, next is which is this line is only touching just a point, just like this. Here, is everybody at least yes or no?
Yes, sir.
Very good. So basically these figures are there. So basically this part is not, this line is not touching the circle surface. Yes or no?
Yes, sir.
So it means that this is a non-intersecting line. Yes or no? Because intersect means either it will touch or it will cross. Two possibilities are there of the intersection. It means that if the intersection word is used, so either the possibility is that it will just touch the surface or either it will cross the surface. Okay? So it is non-intersecting line. Okay. So next thing is that, so second point. So see that, suppose that line, this is a line PQ. PQ line is there. So see that, so 2 points are there of the intersection. It's A and another is B. Clear? Yes or no?
Yes, sir.
So see that 2 points, two common points are there on the line PQ. Yes or no? Two common points
Yes,
are
sir.
there. Yeah? It will basically it's lying on the PQ line.
Yes, sir.
Clear?
Yes,
So
sir.
basically this line is called as secant. Secant. Clear? Secant. And when the line just touches one point on the surface of circle is called as tangent.
Tangent.
Tangent. Okay. So have you like we have done the trigonometry tan theta. How many of you remember that? Sec theta. You
Yes,
remember,
sir.
na? So basically
Yes.
tan theta. So tan theta is the representation of this part. Okay. When we'll basically draw the tan theta, right now you won't be able to understand that because that's a high level you can say concept. So just right now I'm just giving you the idea. So that you can see that these 2 points are common. So that line is called as secant. And this is called as tangent. Clear?
Yes.
So AB is nothing but AB is a chord. But we are
Yes, sir.
taking AB is a chord in the 9th class. I think in 9th class this chord concept is introduced.
Yes, sir. Yes, sir. Yes, sir.
Yeah. But right now we are taking we are taking different terms, secant and tangent. So that's why I'm not introducing that thing. I'm just saying AB is the secant of this circle.
Chapter 10, right?
Yeah, it's chapter 10. Yes. And the tangent is the point. Tangent is the line which touches the circle at a single point. Clear? Only a single point. The point of intersection is only one of the tangent. Clear?
Yes.
It should at only one point. It will only, just don't think that it will intersect at any other point. No, tangent will only intersect at one point only. Clear, everybody?
Yes, sir.
And for one point, only one tangent can be present. If I'm saying that this is the point, so only one tangent will be present. No other tangent will be present. Clear, everybody?
Yes.
Any doubt?
No, sir.
No.
Sure?
Yes, sir.
Very good. So basically, tangent is a special case of secant. How? Just see one thing. Take this line beyond this thing. So point of intersection, basically 2 common points will come closer and closer. Now at this point here, if I take a line which is here, now the point of intersection become closer, yes or no? At this point, the point of intersection become closer or not? At this point, again, Now there will come a point when the 2 points coincide on each other. So that's what the tangent, that's what the case of tangent is. Clear, everybody?
Yes, sir.
Any
Yes,
doubt
sir.
what I've spoken so far?
No, sir.
Sure? Just
Yes,
a
sir.
moment. Okay. So this is the next part is like this is the introduction of the circles and the tangents. Clear, everybody?
Then wrote the name for like those two other circles.
I
Like
didn't
for
get the
the
word.
first one, we wrote non-intersecting line, right? For the second
Non-intersecting
and
line, because there won't be any case because line is not intersecting the circle at any point. Clear?
okay, yes. And for like what will be for secant and tangent?
I didn't get your word.
So what will be the like the name for secant and tangent?
No, nothing. Only secant. Like now, if the line intersects, so there will be this line will called as secant. No, like this is not a name of circle. That's only a case. Like I've given you the case name.
Okay,
Clear?
like the for secant it will be like two common points and like
Two
tangent
common
one
points,
common
yes,
point.
and tangent one common point. And this point is
Okay.
called as point of contact.
Okay.
Clear? Sure? Okay. So
Yes,
let's,
sir, yes.
without any delay, let's do the first theorem because this is all the starting of this theorem first. Suppose that just a second. Theorem first. First theorem. So it says that the tangent at any point the tangent at any point of a circle is perpendicular to the radius through the point of contact. Clear? It says that basically, just a second. So the tangent at any point of a circle is perpendicular. So let me draw the figure so that you can understand this. Suppose that one tangent, basically this is a line. Okay, this is the tangent. So this is the circle. So it says that circle, the radius of circle is perpendicular to the tangent, the point of contact. So basically this angle is nothing but this is 90 degree. That's what the theorem is saying. Clear, everybody?
Yes, sir.
Yes or no?
Yes. Yes.
Okay, so
So can you
basically,
scroll up for just 1 second?
yes, it says,
Just one. थोड़ा सा like yeah, बस, thank you.
okay, do it. So basically what we need to do is that we need to prove this, that the theorem is, just a second. What happened to my laptop suddenly? Okay, so everybody look at the screen first. Okay, so now we need to prove this theorem. So the proof of the theorem is proof. Let's find out what the basically what we need. So how to approach this? Now see that, so OA, suppose that this part is A, this part is O. Suppose that we need to prove that it's always perpendicular. Erase this again. Okay, so this is C. Okay. So basically we need to prove this theorem. So B, let's suppose that B is the, sorry, C is the point here, or you can say B point. Suppose that this is B point and this is C point. C is the radius of the circle. Yes or no? This is also the radius. This is also the radius. Everybody, yes or no? Yes or no, at least yes or no?
Yes, sir.
Yeah. So OA is equals to OC. Why? Radii of circle. Here, yes or no?
Yes, sir.
Now, just see. OB is equals to what? OB is equals to OC plus BC. Yes or no?
Yes, sir.
So you see that OB is greater than, because see that if I say, just you can directly say that OB is nothing but OB is greater than OC. Yes or no? Because if I'm adding something to OB, then it will become, if I'm adding something to OC, sorry, it will become OB, this equation. Yes or no?
Yes, sir.
Sure?
Yes, sir.
So if OB is greater than OC, so it will also be greater than OA, sorry, because OA is equals to OC. Yes or no?
Yes, sir.
Radius and B. Any point on tangent. So again, OA will be smaller than OB. Yes or no?
Yes, sir.
So
Yes, sir.
B is also. Clear? Okay, now see that OA is shorter than all the segments. OA is the most shortest line to all the segments, whether it's OB, whether it's yes or no? OA is the shorter one now.
Yes, sir.
Just a second. Thus OA. There's no like very like equation type thing. Only the statements are there. OA is shorter than any line segment joining O to any point on tangent. Basically, if I need to connect with a tangent, like if I need to draw anything on the tangent, either I can draw this, either I can draw this, either I can draw this. Just see that OA is the shortest point, which is I'm drawing from this center of the circle to the tangent, because OB is greater than OA. So it means that it is basically length greater than OA. So OA is the shortest path, because we have seen that radius is the shortest. That's what we need to prove. Clear?
So what about OC? Is it the same length? OC.
Abdullah, it's not on the tangent, na. OB is on the B point is on the tangent. If I'm taking D
Oh,
point
yeah,
here,
okay.
so D point will be on tangent. We are talking about the tangent. A point is on the tangent.
Okay.
Clear?
Yeah, okay.
Got it?
Okay.
Point
Yes,
on
yes.
tangent. So, and when we know that, basically when we have already seen that the shortest distance of a given point to a line is the perpendicular distance from it. Have you heard this line? Shortest distance is the perpendicular distance. If you want to say that,
Yeah,
just a second.
yes.
Okay. So shortest, this is the statement here. Shortest
So can you go to the start of the proof for this one?
just a second. You should copy from a perpendicular distance. On that line. Okay. So whenever we measure the shortest distance from a line to a point, it's always the perpendicular distance. Clear, everybody? And if the perpendicular distance is there, so it means that the radius is the perpendicular. Basically, this radius is perpendicular to tangent.
Yes, sir.
If I'm saying that this is the shortest distance, if it's perpendicular, so I need to prove that the this radius is perpendicular to the tangent. So if it's the shortest distance, so it becomes perpendicular to the tangent. Yes or no, everybody? Hence, tangent at any point perpendicular to the radius. Whenever you will draw the tangent to a circle, and if you draw, basically, if you draw the radius on it, basically nothing but I'm drawing a tangent. If I'm connecting this point to the circle, so it will always be perpendicular. It can be right here as well. The tangent can be right here as well. This is the tangent. Suppose, just a second. This is the tangent. So if I basically, this is a point of contact. If I am making a line to it, it will be perpendicular to it. Clear? Clear, everybody? This is the proof. Like, there is not any like equations and all. This is a simple proof. Clear, everybody?
Yes, sir.
Yes, sir.
Everybody is silent. Only Karishma, Hiba, and say, what about Adil, Hiba, Abdullah?
What, sir?
I'm asking, is that clear to you or not?
Yes, sir. Yes, sir.
Sure? Okay, that's great. So that's what the proof is. Okay. So let's take the NCERT exam exercise.
So आप proof के start.
Yes, Abdullah?
अच्छा, can you go to the starting of the proof? I'll just take screenshot.
Okay. This is the proof. Take the screenshot.
थोड़ा सा और नीचे, like just exact from proof.
Starting.
No, sir. Below. Yes, perfect. No, अरे sir. Yeah.
Okay.
Thank you. No, एक लाइन ऊपर. Yeah, thank you. Done, sir. Thank you.
Yeah. Okay, so let's come to this. How many tangents can a circle have? Everybody? How many
One.
tangents can a circle have? One. Okay, he said one. What about others? Karishma, Adil, Abdullah.
Sir, 4.
Sir, one.
Okay, okay, Abdullah said one. What about Adil and Karishma? Tell me.
Infinite.
Karishma said infinite. Adil, what's your answer?
Sir, it's
Sir, is it one?
not one.
Okay, Hiba said not one. What is it basically?
Infinitely many.
Infinitely many. So the answer is infinite. Because circle have infinite points and each point will have each tangent. So infinite points equals to infinite tangents. Clear?
Yes.
A tangent to a circle intersects it in
1 point.
one. Intersecting line in 2 points is called a
Secant.
Oh, like that. Okay.
okay. A circle can have how many parallel tangents can be there for the circle?
2.
Okay, Karishma said 2. What about the others?
Two.
2. Okay, Adil said, Hiba said 2. What about Abdullah and Adil?
A circle can have that.
Basically, it will be 2, na? Because if I draw a circle,
Yeah.
one parallel tangent is this, another parallel tangent is this. At most, 2 parallel tangents are parallel to each other. Here, a common point of a tangent to a circle is called the circle. A common point of a tangent to a circle and the circle is called why is everybody silent?
Point of contact.
Yes, point of contact. So trying a tangent PQ at a point P and circle radius is 5 through a point, so center at a point so that OQ is 12. Find the length of PQ. Can anybody draw the figure of it and find out the value? It's not nothing but it's Pythagoras theorem.
Yes, 13.
How many of you remember the Pythagoras theorem?
Sir, answer is 13, right?
Karishma, you have to solve it.
Sir, I
Don't say
did.
this.
That's why.
Okay, you got it. Very good. Okay, so you are saying 13. Let's find out whether you say whether your answer is correct or not. At least try.
Sir, it's root 119.
Okay. Hiba said root 119. Adil and Abdullah. Karishma said 13.
Sir, this was like exercise 10.1, right?
Yes, yes, yes.
Okay, sir.
What happened? Everybody, only Hiba and Karishma has given the answers.
Sir, D option.
The option. Okay. Why change? Why you have changed the answer, Hiba, Karishma? You were so confident about the answer 13.
मैंने दोबारा से सॉल्व किया था इसलिए।
Okay, so that's why overconfidence is not good.
Yes.
Okay, like I'm not
Yes.
demotivating you. I'm just telling you that sometimes it seems that it's very easy, but when you solve this question, it looks the answer comes out to be different. Clear? So basically, the answer is 1 root 119. Nothing but this saying that just like this. This is 12. This is 5. Okay, so it's nothing but so
Sir,
144 minus
sir,
25. It's
it's basically like पहले इस्तेमाल करे फिर विश्वास.
I don't know the concept like what
उसने
it is
बोला उसने
basically.
आंसर दिया भी नहीं है।
Okay,
Sir,
okay, don't,
sir, like it's a
don't
slogan of,
fight.
क्या बोलते हैं, detergent company है,
Detergent, I know,
उसका
I
है.
know. Acha, don't like fight. Right now we are in the class. Okay, so let's find out the terms. Next thing. So that the basically this part, the tangent, basically what it basically is very easy. Like they are not very good, like various numericals. Only this kind of question will be there. Like how many point, what is the name of the point of basically at point at its contact, how many tangents can be there, and two, how many, like basically what is the common point. So that's all these kinds of questions will be there, and this Pythagorean question. So question will comes out in the next topic. It's a very small chapter. I think in the coming class it will be done. Okay, to a circle. Clear, everybody? Number of point, basically number of tangent. How many tangents can be drawn from a point on a circle? Okay, so this is a theorem. Suppose that I have a 1 point. It's asking, like I'm just telling you how many tangents will be there from a common point. Okay, 1 point is there. I have to draw tangents on this circle. So one tangent will be this, and one tangent will be this. So maximum of 2 tangents can be drawn from a given point. Clear, everybody?
Yes, sir.
Any doubt?
No, sir.
When you basically the given point is there, so you can only draw 2 tangents on the, yes or no, at least yes or no, on a circle. Clear, everybody?
Yes.
Very good. So let's come to the theorem, because next is the theorem part, not a very good thing. Okay, so this, suppose that this is P, this is point A, and this is point B. So this part, like PA, is called as length of tangent. Okay, everybody?
Yes.
And basically we need to show that in the coming theorem is like basically the theorem I'll be taking right here is show that this tangent is equal, this distance between these 2 points are equal. Basically, PA is equals to PB. So basically, this is a property you can say from the theorem, but right now we are just proving it. Okay, so let's prove this theorem. The length of the length of tangents drawn from external point. Here, everybody.
Yes, sir.
Okay. Now, what we need, let's draw one more figure here so that I can explain that thing to you. This is P, this is A, and this is B. Suppose that this is a circle center. What we need to do is that we know that the radius to the point of contact is perpendicular. Yes or no, everybody?
Yes, sir.
Okay, and this point will be this connected to this. So this is O. Okay, if I need to prove that PA equals to PB, I need to prove that P and triangle POA or triangle AOP or triangle BOP are congruent. By CPCD, I can use that PA equals to PB. Yes or no, everybody?
Yes, sir.
So what we need to do is that let's come to the proof.
In triangle PAO
No, first we
and
need
P.
to write the contract, like what we have, you can say, they constructed. Clear?
Yes, sir.
Perpendicular. OP. Clear? Yes or no? To prove PA is equals to maybe let me do it. Okay, everybody. So, so now say that OA will be equals to OB. Why? Let me take in triangle.
A radii of same surface.
AOP and OA will be equals to OB, radii of circle. Yes or no, everybody? Just give me a moment.
Yes,
Let me
sir.
check. Like, just let me check whether it's possible to conduct your assessment or not, because I just want to check. Yes, yes, you will say obviously no. You are not attending the class with a very focused mind, but it's not good, na?
Yeah. Spare us.
Yeah. So there is an assessment. Okay, everybody.
Did it start? Like you started the assessment?
No, right now, like at 10:30. The assessment will be at 10:30.
10:30. So basically at like 8 o'clock here.
Yes, in Saudi it's 8 o'clock.
Okay.
Just give me a moment. What does that? So OA is equals to OB, yes or no, by the radius? Yes or no?
Yes, sir.
Why is everybody so silent? I don't know what.
Yes, sir.
Yes, okay, that's great. And OP is equals to OP common and angle. It's angle OAP or P. It's angle PAO or angle. Okay, just say angle A is equals to angle B, right angle. So triangle AOP is congruent to triangle BOP by RHS. RHS is a kind of criteria in the congruency. Okay, clear everybody? At least somebody says yes or no.
Yes, sir.
Very good. So basically, so that's why the triangles are congruent. Clear? Let me enable the text. Okay, Adil said yes. It's M4 batch or M5 batch? Can anybody tell me? I'm a little bit confused. M4, it's M4. Yeah.
So what does this M3, M4 mean?
The batch number, dear.
Oh, so you have like 4 batches for a 10th grade?
No, I don't have, like other teachers have.
Okay, like that. Okay.
Okay, clear everybody? So from CPCD, can I say that PA is equals to PB?
Yes, sir.
This PA is corresponding to
Congruent parts
PB,
of
yes or no?
no, sorry, corresponding
Corresponding
parts of
parts of congruent
congruent
triangles.
triangles. Yeah.
Very good. Hence
Corresponding.
proof. That's what we need to prove. Hence, proof. Whenever the two tangents are drawn from an external point, they are equal in length. Clear everybody?
Yes, sir.
Yes,
Any doubt?
No, sir.
Very good.
Okay.
So that's what the theorem is. This is a simple theorem, not very, you can say that long and very complex theorem, just like in the BPT. It's a very straightforward thing. Clear? Yes or
Yes,
no?
sir.
Yes, sir.
Very good. So basically right now only 6 minutes are left. I don't think so that any question can be done. Because a little bit concept, or you can say these questions will require
So you start the assessment. We'll do it right now.
assessment is like will be active in 1 minute. At 20
Okay.
20 will be 1 minute. It will be active in 1 minute.
At like
7:50. It's 7:55 according to the UAE to Saudi time, and it's
so
8:55
it's already
according to UAE
7:55
time.
here. Like
Yes. Okay. Yeah.
7:56
Now
or
the assessment
7:50.
is active. Assessment is active right now.
Okay, so
Go and give, like, don't leave the class. Go and attend the assessment and let me know